Okay, we're going to make a little cheat sheet video for solving absolute value equations and solving absolute value inequalities. All right, now whether it's an equation or an inequality, we have to first isolate the absolute value expression if necessary. That means getting the absolute value expression alone on one side of the inequality or equation. So for here, we have the absolute value of x plus 2 is equal to 9, right? We need to subtract 2 from each side, okay? That cancels these out. And now we have the absolute value of x is equal to 7. Now that we have the absolute value expression isolated here, we're able to work with this problem. Okay? Here, we'd have to add 5 to each side to solve. Here, for 2x minus 5, the absolute value of that equals to 13, we're already set up and we can start to solve this problem. The absolute value is isolated on one side. Now, when you do this, once you have it isolated, you're going to set it equal to whatever the numeric value is on the other side of the equation or inequality. And you're going to set it equal to the positive version of that and the negative version of that. Because that means that this expression of 2x minus 5 is equal to positive 13, because the absolute value of 13 is 13. But also, this 2x minus 5 is equal to negative 13. Because if we got negative 2x minus 5 to equal negative 13, when we took the absolute value of that right here, it would still equal 13. All right, so when you have your equation, you'll have one or two answers that will be correct depending on what your expression simplifies down to. Okay, now when we have absolute values equations with no solutions, to solve this problem, we do not have an isolated absolute value expression. We'd first have to subtract 12 from each side, and we'd get 3 times the absolute value of 2y plus 9 is equal to negative 3. And then when we divide by 3 on each side, all right, we'd isolate the absolute value expression, and we'd have a negative number on the other side. So when we work this out, it'd be the absolute value of 2y plus 9 is equal to negative 1. All right. So I can actually show you that with steps. So we'd subtract 12 from each side. All right, and then we'd end up with 3, and then times the absolute value of 2y plus 9 is equal to negative 3. Sorry, I have to draw the lines in later, can't type them in. All right, and then we would divide by 3 on each side. And when we do that, that's going to cancel these 3's out. And we're left with 2y plus 9. The absolute value of that is equal to negative 1. Okay, so again, when you have the absolute value set equal to a negative number, that's not possible because there's no way we could take the absolute value of something and have it equal a negative. So when that happens, there's no solution. Okay, our answer to that is a no solution. Moving to absolute value inequalities. It's very similar. Okay, you're going to isolate an absolute value expression, and you're going to set it, instead of equal to it, you're going to have it be the same thing. It's going to first be that we have x minus 1 is less than or equal to 3. And the other thing we would have then is x minus 1 is greater than or equal to, and it would be, negative 3. So what happens is you take the expression and you keep the inequality symbol and whatever isolate constant number is on the other side, and that's your first inequality to solve. In your other inequality, you have the same expression, but you're reversing the inequality symbol, and it's essentially like multiplying the constant by negative 1. All right, so when you multiply or divide by a negative number, it reverses the inequality symbol. And then you'll solve this way. Okay, now you have different types of answers. We talked about one or one answer, two answers, or no solution for equations. It is different when you have inequalities. Okay, when you have an absolute value expression that is less than a number or less than or equal to a number, then it's going to be a compound inequality in the form of an and, right? You're going to have some negative number is less than or equal to the expression is less than or equal to or less than the positive version of that number. Now, if you have the inequality the absolute value expression isolated and it's a greater than situation, that's going to be an or compound inequality. You're going to have that expression is greater than some number, or that expression is less than a negative version of that number. Okay? So, again, just like the equations, you have to get the absolute value expression isolated. If it's less than the constant, it's an and compound situation. If it's greater than the constant, it's an or situation. The last situation is when there's a special case. Okay? And it's very simple to recognize these. Again, you need to have the absolute value expression isolated. If the absolute value expression is less than a negative number, that's not possible. Okay, we can't have the absolute value of a number be less than a negative. It'll never work. There's no solution for a situation like that. As soon as you see the absolute value expression isolated and being less than a negative number, you're done. There's no solution. No number you could substitute in to make that true. Now, the other special case is we have an absolute value expression. We need to isolate it, so we're dividing by 3 on each side. So you have the absolute value of x plus 2 is greater than or equal to negative 4. Now this is different. We had the less than a negative. This time it's greater than a negative. Well, the absolute value of anything is always going to be greater than a negative. So when that happens, it's an identity. It's all real numbers. It's infinitely many solutions. Any number we substitute in will always make it be a larger number than a negative. Okay, and that's our special cases. I hope this video helps you as a quick cheat sheet to how to solve absolute value, inequality, and equations, and hopefully you can recognize the little nuances that go with it.